Okay, so if you've ever thought about, mushroom foraging, maybe just pause for a second. Because today we are diving into a world where um, absolute precision is pretty much the only thing separating a delicious meal from, well, systemic organ failure.
Yeah.
We are exploring the dual lives of the deadly fungi kingdom.
It really is nature's highest stakes activity, isn't it? You're trying to navigate, 14,000 known species of fungi
Right.
and figure out which one belongs on your plate and which one is uh, actively plotting your destruction.
And the margin for error is it's frighteningly small. We're talking about the fact that only about 10% of known species are genuinely edible.
Just 10%.
The rest are either just inedible or, worse, lethally toxic.
And that remaining 1 to 2% of toxic species, they're responsible for hundreds of deaths globally every single year. They are potent, they're deceptive, and they represent some of the most specialized biological warfare on the planet.
Yeah.
Really.
So our mission in this deep dive is to try and understand these two extreme facets, right? The quiet assassins that target humans, and then these bizarre, almost revolutionary parasites that turn insects into live puppets.
That's a good way to put it. Live puppets.
Okay, let's unpack this. When we talk about human fatality, we have to start with the undisputed heavyweight champion, the death cap, Amanita phalloides.
Oh, yeah. A big one.
This single fungus is responsible for the vast majority of toxic mushroom deaths annually.
It is terrifying. And not just because of its potency. Get this, less than half a cap can kill a healthy adult.
Wow, less than half.
Yeah, but it's also its silent strategy. Its power is ancient. History tells us about Roman Emperor Claudius, reportedly killed back in 54 AD by his wife Agrippina, using the death cap, probably to clear the path for Nero.
So the lethal agent here is amatoxin, specifically alpha-napkin. This isn't just a poison. It's like a biological time bomb, right? Designed to exploit our own metabolism.
Exactly.
But if the death cap has been known for millennia, why haven't we developed some kind of robust, reliable antidote for amatoxin? What makes it so incredibly resilient?
Well, that's the critical point, isn't it? The toxin is heat stable.
Meaning cooking doesn't...
Doesn't make it safe. Nope. Its mechanism is highly specialized. It targets this enzyme, RNA polymerase II, which is absolutely essential for synthesizing proteins, particularly in the liver.
Okay.
So by disrupting this core function, it just causes cellular collapse. There's no simple chemical countermeasure you can just, take.
And the agony timeline you mentioned, that's the most sinister part, I think. 6 to 12 hours after you eat it, you get the classic horrible GI symptoms, nausea, diarrhea.
Right, standard food poisoning stuff, you might think.
But then you feel better. There's this deceptive short reprieve.
And that's the moment the toxin has successfully navigated the intestines. It's making its efficient, unimpeded way straight to the liver.
Oh, that's chilling.
Yeah. It's only 1 to 7 days later that the full horror begins. The toxin annihilates the liver and often triggers kidney failure, too. A liver transplant is frequently the very last line of defense.
And this toxin, amatoxin, it's not unique just to the death cap, is it? It has cousins, the destroying angels.
Fair.
They also pack that lethal punch.
Right. They are pure, sort of ethereal white, which makes them really easy to confuse with harmless edible things like meadow mushrooms or button mushrooms.
Innocent looking.
Very. And North America has its own highly lethal variants like the Eastern Amanita biscarigera. Shares that same deceptively clean, pure white appearance.
And we also see amatoxin in these tiny, unassuming ones, like the deadly dapperling and Galerina autumnalis.
That's right. And that Galerina is often mistaken for psilocybe species, magic mushrooms.
Oh, dangerous mistake.
Or even edible honey mushrooms that grow on rotting wood. It's kind of proof of successful convergent evolution, really. Multiple different fungi families arrived at the same ultimate weapon to deter anything eating them.
Okay, so we've seen fungi that kill silently by destroying internal organs. But other fungi have completely different toxic strategies, often involving visual warnings or these highly delayed assaults.
Exactly. Let's look at the iconic phylagric Amanita muscaria. You know the one?
The classic fairy tale toadstool, red and white spots.
Yep. That striking cap is basically the visual equivalent of a massive siren going off. It rarely kills because, honestly, nobody mistakes it for dinner.
Right. It screams, "Don't eat me."
It really does. And instead of amatoxin, this one uses ibotenic acid oxotoxins, which attack the central nervous system. They can cause seizures, coma, potent hallucinations. It prioritizes defense by making itself incredibly obvious, not hidden.
A different strategy entirely.
Now, here's where it gets really interesting regarding those delayed strategies you mentioned. Consider the deadly web caps. They're from the Cortinarius genus, natives to northern Europe.
Okay.
And they look suspiciously similar to edible winter chanterelles.
Oh, another look-alike problem. So what's their toxin?
Orellanine.
Yeah.
And it is the ultimate slow burn assassin.
How slow are we talking? How long is the lag time before symptoms even appear?
Symptoms can take upwards of 3 weeks to appear.
3 weeks? Seriously?
Seriously. Orellanine works by physically destroying the cells of the kidney tubules. So by the time you notice any significant discomfort or maybe finally get a proper diagnosis, the damage is often irreversible.
Wow.
That delay is terrifying because treatment efficacy just drops drastically over that time.
It's a completely different mechanism than the liver-targeting amatoxin then. Just goes for the kidneys slowly.
Exactly. And then we have the false morels, Gerometra esculenta, often mistaken for the delicious true morels, which people prize.
Right. Morels are a delicacy, so what's the danger with the false ones?
The danger here is gerometrin. Your body metabolizes this into monomethylhydrazine, which is, believe it or not, a toxic ingredient used in rocket fuel.
Rocket fuel? You're kidding. Yeah.
Not kidding. Now, fatalities are rare these days with modern emergency care, but it will absolutely make you incredibly ill. And just to be clear, even true morels contain small amounts of toxins. They absolutely must be thoroughly cooked. Those toxins break down with heat, unlike the amatoxins we talked about, or the gerometrin.
Got it. Okay. So we've seen fungi target our vital organs, our nervous system, but the true evolutionary, maybe horror show begins when fungi stop trying to kill us and start trying to, well, control something else entirely.
Yes.
Let's pivot from human killers to the ultimate parasites. The Cordyceps, the notorious zombie makers.
This is really where biological adaptation enters, like science fiction territory. Cordyceps is a huge genus, over 500 parasitic fungi, mainly found in warm, high-humidity Asian climates, and they exclusively attack insects and arthropods.
Now, everyone familiar with popular culture, like games or movies, thinks of them as literal mind controllers, right? Driving their hosts like a puppet master.
That's the common image.
But newer research seems to be correcting that premise, showing the mechanism is maybe far more bizarre than actual neurological control.
Right. This raises an important question. Is it truly mind control? When we look really closely at the most famous example, Ophiocordyceps unilateralis, the one that attacks ants,
Yeah.
we find the fungus leaves the ant's brain mostly unaffected. The brain is still there, largely intact.
So wait, if we think of the ant like a computer, the fungus isn't rewriting the hard drive, the brain. It's doing what? Bypassing the operating system entirely?
Pretty much. It's controlling the physical hardware, the muscles and movement directly with its own biological wiring. It is essentially making a live puppet, like you said earlier.
That's even creepier somehow.
It kind of is. The fungus actually replaces the muscle tissue of the host with its own network of mycelia fungal threads. Then, when it's ready to sporulate, it uses that physical network it's built inside the ant to compel the ant to climb up tall vegetation. Lock its jaw onto the north side of a twig or a leaf in this death grip. It's the ideal location and orientation for spore dispersal.
That fixed death grip is the final act then. The fruiting body, the stromata, then sprouts directly from the back of the dead ant's head, releasing spores to rain down on the colony mates below, continuing this macabre cycle.
It's a physical takeover, not neurological.
Yeah.
An extremely specialized fungal adaptation. It's just remarkable.
A remarkable, if terrifying, evolutionary success story for the fungus.
Definitely for the fungus.
Oh.
And while they are absolutely lethal parasites to insects, the relationship between Cordyceps and humans is, perhaps surprisingly, often beneficial.
Okay, let's shift perspective entirely then. Fungi as healer and protector, how does that work with Cordyceps?
Well, Cordyceps have been prized in Chinese and Tibetan traditional medicine for literally thousands of years.
Thousands.
Yeah. The key traditional species is Ophiocordyceps sinensis. Now, this one takes a slightly different path. It turns its host, which is the ghost moth caterpillar, into a mummy, not a zombie.
A mummy.
Yeah. It sprouts exclusively from these victims at really high altitudes, like on the Qinghai Tibetan Plateau.
And its rarity, I assume, and perceived potency used for things like asthma and respiratory inflammation make it incredibly valuable.
Hugely valuable. It's one of the most valuable natural ingredients in the world, pound for
Oh,
pound.
wow.
But unfortunately, its high value led to massive overharvesting, placing O. sinensis on the endangered species list in China.
Oh, that's a shame.
It is. Thankfully, another species, Cordyceps militaris, which much easier to grow commercially, is often used now as a cheaper, more sustainable alternative in many preparations.
Okay, so beyond ancient medicine, humans are now finding ways to put cordyceps to good use as eco-friendly pest killers.
I like the idea of Cordyceps as nature's Dexter,
Yeah.
targeting and controlling specific pests.
Huh.
That's a good analogy. And it's a really essential area of study because, as you know, synthetic insecticides often kill indiscriminately. They negatively impact beneficial insects, like the natural predators that should be keeping pests in check.
Right. So how are researchers using them?
Well, for instance, they're fighting pests like citrus leaf miners by deploying specific species, like Cordyceps canica. This fungus parasitizes only the pest insect, leaving the helpful natural predators unharmed on the battlefield, so to speak.
That's clever. Targeted biological warfare.
Exactly. And in agriculture, particularly against things like the coconut root grub, which can destroy crops, blanket spraying harsh chemicals is just unsustainable. So scientists are investigating how species like Cordyceps militaris can naturally prey on these grubs to control populations without all the damaging side effects of widespread insecticide use.
That makes sense, but I guess it requires careful research to make sure the fungus doesn't jump hosts or become invasive itself.
Absolutely. That's a critical part of the research ensuring specificity and safety.
What a journey we've been on. From the, microscopic amatoxin annihilation in the death cap to the slow, agonizing kidney killers like the web caps, and then this large-scale ecological control exerted by the Cordyceps genus.
What's truly fascinating here, I think, is the sheer evolutionary adaptability of the fungi kingdom. It's just incredible. They range from requiring just a subtle color change to confuse a forager,
Right.
all the way to developing this complex parasitic mechanism that bypasses the brain entirely and physically replaces the muscle tissue of an insect host.
It fundamentally changes how you look at a simple mushroom, doesn't it? Or even just an ant walking past.
It certainly does.
Yeah, that's cool.
We've seen fungi that kill by design and others that heal almost by accident of nature from our perspective.
Yeah.
But here's a thought. Given how much of the insect's world is susceptible to this kind of fungal control, turning them into these live puppets, we have to wonder what biological defense mechanisms might be preventing these incredibly adaptive fungi from evolving to control creatures with more complex nervous systems, like, say, humans.
Ooh, that's unsettling.
Something for you to mull over or maybe explore on your own.